What if I tell you that the secret to building more reliable systems is actually breaking them on purpose? That is the core idea behind chaos engineering, and it's evolving fast. And as systems scale faster than teams can manage, the old playbook of dashboards and alerts isn't enough. Now, AI is entering the reliability stack not just to detect issues, but to predict, prevent, and engineer for failure before they actually happen. In today's episode of An Eye on AI, I am joined by once again Kolton Andrus, CEO and founder of Gremlin, the company that pioneered chaos engineering at scale. And Gremlin is back with Reliability Intelligence, a new platform that combines AI, failure injection, and real time observability to help teams move beyond incident response and towards proactive automated reliability. In this conversation, we will explore the current state of chaos engineering, how AI is changing the resilience landscape, and how platform teams can build systems that not only survive failure but actually learn from them and get better. Colton, it's great to have you back on the show. What is the current state of chaos engineering and how has the practice evolved since it emerged as Chaos Monkey at Netflix?
That's a great question. So I think we've seen chaos engineering evolve quite a bit over the last 5 years. And some of that is good news and some of that was bad news. I think I wrote this great blog post called Chaos Engineering Necessary but Not Sufficient. So I think chaos engineering is a very important tool. And I think when it's used correctly, it's immensely valuable. But what I observed in the market over the last 5 years is people really struggle to use the tool correctly. They often have it be kind of a one-off thing some SRE teams do. It lacks visibility. It lacks accountability. It lacks a good way to measure. And so it's a bit of best effort. And if you do chaos engineering best effort, you get, kind of mediocre results. Whereas we've seen a lot of people approach it in a much more systematic way. Hey, we're going to, track this across all our teams. Hey, we're going to measure the impact. We're going to see if we're getting better. We're going to, hold people accountable to results. And we see with those companies, very, very good impacts, very good improvements to their reliability.
As I was listening to you, and in the last 4 or 5 years, the systems have grown more complex. Now, AI has started to play a big role in operations as well. What do you see as the most important ways AI can support reliability and resilience in production environment? And it's the same case with you. No matter what kind of conversation you're having, AI just seeps in. AI is too smart to seep into almost every discussion. I had this 3 interview this morning. Almost everyone was about AI in one form or the other. So I want to hear your opinion on AI in terms of the whole reliability.
Yeah. So my favorite way to put it is if Skynet comes about tomorrow, it's going to fail in 3 days. So I'm not worried about the AI apocalypse because AI isn't going to be able to build and maintain and run reliable systems. I think AI is great. I think there's a lot of things it's good at, speaking like humans, helping us interact with computers more easily, doing some basic, thinking and reasoning for us. I think AI is not yet great at, large scale distributed systems. As you mentioned, there's a lot of complexity. There's a lot of moving pieces. There's a lot of things it needs to get right. But it's also that a lot of the LLMs and a lot of what we talk about in the AI world is really non-deterministic. And when we're talking about distributed systems, we care about it working correctly every time, not just most of the time. So from my perspective, AI code is going to give us plenty to do. We need to go do more testing. We need to do more verification. We need to make sure the code that's been created is reliable. We need to make sure AI has heard of things like circuit breakers and exponential backoff and good timeout tuning. So I think that's kind of where I'm at when it comes to AI within reliability. I think on the flip side, we're using AI within Gremlin. So, what is AI good at? Well, in our world, we've always wanted to do more for the developer. Hey, you ran a test. Let us tell you whether or not your system passed or failed. Hey, you ran a test. Let us tell you how to go fix it and what to go do next. And so in that world where we want to offer up suggestions and guidance, we don't need the deterministic 100% correct answer. We can go through and we can tune the model to be able to give people really good advice. So that's what we're doing internally. We built something that builds in a lot of advice and recommendation and guidance on what to do after you found a failure. And we think AI is a great solution for that.
You folks are also launching reliability intelligence. Can you walk us through what is that, what that includes, and how does it change the way teams approach chaos engineering and incident prevention?
Our vision has always been, do as much as possible for the developer. So we want to, in the beginning, it was, we'll have all the tests, we'll run the tests for you. And then what we needed was we needed a way to tell whether the system was healthy. We needed a way to tell whether the system behaved correctly. So we went and did a lot of work and integration around reliability management, around integrating with monitoring, around analysis to tell people, hey, your system passed or failed. But that was kind of 2 steps along the way. The third step is now let's tell you, you ran the test, whether you passed or failed the test. Now we want to tell you how to go fix it. And what's fun about this is there's a little bit of LLM involved, but there's a lot of classic machine learning. We have a lot of data, a decade's worth of people running failure experiments and learning from them. And we've derived from that a set of recommendations, a set of guidance. And so, when you run a test now with reliability intelligence, we're able to tell you, hey, here's why the test failed, and here's what you need to do to go fix it. And those are concrete suggestions. Hey, we saw this exception in your log. It's kind of like Stack Overflow. Here's how to go fix that exception. Sometimes it's something more interesting though. Hey, we've noticed that your dependency consistently fails. You should really go put a circuit breaker around your dependency. And that's an opportunity for us to guide them, to teach somebody to not just say, hey, here's a problem, go fix it, but here's a problem and here's 3 ways you might go fix it. Would you like to learn more?
When it comes to chaos engineering, it is often championed by advanced teams, advanced users, which is the fact. But what about what kind of adoption curve look like for mid-size or new organizations? Are you seeing that they're also embracing it, or there are things that are holding them back from fully embracing chaos engineering?
Yeah, so I think back to, the biggest problem we've seen with chaos engineering the last decade is the approach and how you implement it. And so we've seen small and mid-sized companies, take it to heart, build it into their process, tell teams it's important, build up, test suites that they look at regularly, look at reliability scores, ask questions about why things aren't good enough. And so we see, small and mid-sized companies have a lot of value and have a lot of success with that approach. We see small to mid-sized companies who also hire an intern and say, hey, intern, go figure this out for us. And they get, pretty mediocre results as a result. I think you see with the big companies, you see the same thing though. You'll see teams where, they come in and they give it a shot, but if they're not really measuring it, if they're not communicating it to leadership, if leadership isn't seeing the value, it's always a short-term project. It's not really, it doesn't become baked into the process. And conversely, we see with some, very large Fortune 100, Fortune 500 companies, if they make it important. And so the analogy I draw here is to that of security. It's very rare that you go to the security team and they say, well, security is nice to have. If you get to it, that would be great. If not, I guess we'll just have an outage. That's a lot of how companies treat reliability. And when they treat it with, the proper amount of respect is the word that comes to mind, but the proper amount of guidance, the proper amount of organizational buy-in, you see much different results. And it can be, it's kind of like, hey, should we write unit tests? Hey, should we do integration tests? Hey, should we do distributed system tests to make sure things work correctly? And once it just becomes part of how you do things, things work well. But again, it comes back to people need to know what to do, and leadership needs to value it and needs to have a way to measure and know that it's important.
Is there any myth that you have seen about chaos engineering or reliability that you feel we need to address or unlearn?
We've probably talked about this before, so I appreciate the question. I think chaos engineering is a bit of a misnomer. A lot of people think, oh, we're going to go cause chaos and see what happens. And it's the opposite. We want to engineer the chaos out of our systems. We want to know how things behave. And so I think similarly that, yeah, probably my pet peeve is a lot of people come up to me and they say, oh, you're doing chaos engineering. Ho, 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 we have enough chaos in our system. Oh, things break all the time. So we don't need chaos engineering. And I just have to chuckle because those are the people that need it the most, not the people who need it the least. And they've just become so desensitized to the pain that they don't realize that there's a solution to it.
The interesting thing with the chaos engineering is, or reliability, is that it is not chaotic, it's very organized. And this is also one of those aspects where the whole team is involved. It is often seen as a shared responsibility. But when it comes to ownership, because of the team and organization, it gets fragmented between SREs, developers, platform engineering teams. How do you see that shifting, and how does Gremlin help organization unify their workflow?
Yeah, I think the classic adage here is if it's owned by everybody, it's owned by nobody. And we see that all the time. Oh, I'm busy focused on this thing. The SRE team will take care of it. The platform team will take care of it. My dependency will take care of it. So how do you fix that? I think it comes back to accountability. One of my favorite questions is, we know how someone could cause a bad enough outage and get fired. But if somebody prevents enough outages, how do they get promoted? How do you measure the benefit that's happened? We're really good at measuring what didn't go well. But if things improve year over year, do we take a step back and congratulate people and promote people? I was just reading a story this morning on LinkedIn about a team that had done so much great work that leadership decided to downsize the team after 2 years with no outages. Well, I got bad news for that team. They're about to start having more outages because that doesn't happen for free. It was the good work of that team that was really preventing things. And so, yeah, does leadership care? Does leadership have a way to hold people accountable? So we built a reliability score, and we think that's a good measure of risk. How risky is the system? How much risk has been mitigated? And so if leadership has that visibility, they can go ask questions. Why is this service more risky than this other one? Why haven't we gone and corrected our ability to handle an AWS zone failure or a GCP region outage? Those are important questions that, need to be answered. And if they can be answered and people can be held accountable or people can be rewarded for their good efforts, I think you see the right behaviors naturally occur.
With reliability intelligence, how do you ensure that AI recommendations are trustworthy and actionable? As you also initially mentioned that if Skynet happens tomorrow, you won't be worried, which kind of points at that we do need human intervention. So can you talk about, with reliability intelligence, how do you ensure AI recommendations are trustworthy and actionable, especially in high stake environments where false positive can be disruptive and it can tarnish brand of an organization?
The naive approach would just be take your data, shove it into an LLM and see what comes back. And that's not the approach we took. We thought, oh, that's risky, and are we going to be able to trust the results? And we care deeply about credibility in our space. We care deeply about giving good advice. We would rather give no advice than bad advice. And so we're not using LLMs for the actual advice portion. We've gone and we've built our own, ML, machine learning data structure based on the behaviors we've seen from our customers. And then our engineering team went through and hand-tuned that model. They went through and they said, hey, we know what certain outcomes should be here. And so they basically traced it down to all the leaf nodes. Hey, here are all the recommendations we want to make. And then again, we used AI to help us generate the initial set of recommendations. But then a person went through each one, read it, said, does this make sense? Is this the right advice we want to give? So that's how we've balanced it. We're using it to kind of prototype and to get some early data, but then we're really hardening it on, real world expert advice from real people in the end.
Does the platform learn from past incidents, context matter, or test outcomes to improve over time, or not? And how does AI evolve with the customer's specific environment? Because every customer is different.
So, one thing I would say is, as much as every customer is different, we have the same 10 things that go wrong in computer systems all day. And so we test those, same 10 building blocks. We cover a lot of ground. There's a lot of different ways in which things get put together, though. I think in general, this idea of the AI system that learns and adapts is very interesting. I actually did a research project when I was still working at Netflix where we were doing an autonomous agent that was observing requests, mapping out the request chain, the request graph, deciding where to inject failures and injecting failures on a very small set of production traffic, 0.001%. But that was in the goal of, really learning and discovering failures that we hadn't found yet, things that we hadn't seen yet. So I would say this is a bold new territory and something we're excited to explore, but something we haven't built yet. And this could go a couple of directions. One is the agent could be an AI agent. We could release the gremlin into your environment and the gremlin could look at what's going on, observe behavior, come up with a set of hypotheses, things that think could go wrong, run those set of tests, measure the health of the system, and then make sure that, if the test failed, it quickly cleans it up and notifies the user or goes and tells the user that it passes. But I think this comes back to kind of where I have discomfort around AI in an SRE world. Do you trust this program to go take action on your production environment without oversight, without being, supervised? And the answer for me today is no. No, I don't trust an AI SRE or an LLM to go make production level changes. I think that's risky, and I think we require a lot more work and hardening to get to the point where it's built that kind of trust and credibility. There's this great IBM quote that I'll paraphrase, but essentially it's, the computer can never make a management decision because the computer can never be held accountable. And so similarly, if the AI SRE makes the wrong decisions, or if the Gremlin AI makes the wrong decisions, whose fault is that? Who gets held accountable? What is the action that happens there? And so I think these are very interesting questions, ones we're talking about regularly, ones we're thinking about. And this world where we could kind of trust the AI to let it loose and find all the problems and tell us how to fix them is the panacea. I think it's quite a ways out, but we want to be working there. That's how we help technology evolve.
Where does reliability intelligence fit into the typical observability or incident response stack? And how does it integrate with tools like PagerDuty, Datadog, or OpenTelemetry?
Yeah, so less on the incident response side, but more on the observability side. So Gremlin has a lot of deep integrations because we need to see what's happening in the system to make the right decision. And so that's integrating at the load balancer level. Let's look at the traffic flowing through your service. Let's look at the error rate for that service. Let's look at response times and see if response times have gotten better or worse or what's happening on those regards. So all of those inputs are what we're leveraging to make the right decisions within Gremlin. And some of those are simple decisions. Hey, if things look too bad, just stop it and clean it up. Some of those, though, very much factor into the kind of recommendations we've seen. Hey, we saw error rate spike, but latency remained flat. Well, that's probably a different type of failure than latency shot through the roof. Oh, that's, we're looking for some kind of long pole that got introduced or some kind of network latency in a loop. So I think that's where we have that opportunity to really look at the observability data, tie into it, and use it to drive the decision making so that we're making the right decisions about testing the system and how to go fix it.
And how customizable is the chaos experimental logic? Can organizations team define their own risk models or tolerance threshold, or is defined by Gremlin?
Yeah, so on the general Gremlin product, we try to make everything as customizable as possible. We're really building the Legos, the building blocks, and you can come put them together in the way you want. And there's lots of complicated ways you can make, series of events, and you can make decisions based upon how past steps have gone. So at a high level, that's what we're using.
As you're talking about the whole evolution of chaos engineering, where do you see chaos engineering becoming part of the larger stack, or part of the software delivery pipeline, fully automated? Like, we look at CI/CD. I mean, initially CI/CD was Frankenstein monster. Then now open source projects start coming in, and Jenkins and a lot of other things are there which are fixing the issue there. I mean, of course, from Netflix also a lot of that also work came out in terms of the whole CI/CD pipelines there. What do you see? Where do you see the future of chaos engineering?
Yeah, so I think it fits in like other testing approaches into a few different places. So I think the CI/CD pipeline is a great one. Just like the unit test, the integration test, we want to run the failure test. We want to make sure things haven't regressed and things are behaving correctly. The thing that's a little different about chaos engineering tests are we want to run them on real systems. So you have to have a system live to do it. Unit tests, you can just run in a library. You don't have to deploy the whole environment. Chaos engineering tests require an environment and they take longer. They take seconds to minutes instead of sub-second time. So typically best practice is customers will run their tests out of band on their deployment, and then they'll make a decision based upon whether to, turn that deployment on or not based upon whether those tests passed. Similarly, you see people just run these tests on a regular basis. So it doesn't have to be part of CI/CD. Some teams treat it like load testing. We load test, the first Friday of every month. We failure test, every Friday of the month. And they'll go through and they'll spend an hour. I think here's one of the misconceptions I hear a lot about chaos engineering and reliability. Oh my gosh, my whole team has to stop what they're doing to work on this for the next month. And the answer is no. If you just got your team together for an hour a week and let them go do incremental testing, you'd make a ton of progress and mitigate a lot of risk without spending a lot of time. And so teams are doing this by hand and then they schedule it. They say, hey, we've run these tests. We know they're working well. We're going to automate them. At Gremlin, we practice what we preach. I have every engineer on my team takes a turn being on call, and whoever is on call for the week runs all of the Gremlin tests that week. Many of them are automated, so sometimes it's just following up to make sure the results have worked well. But if something fails or doesn't work right, the on-call goes and debugs it, and they diagnose it, and they fix it. And that's one of the reasons we've been running at, greater than 4 nines. I won't say 5 or 6 because those are too small a numbers to be real, but we've been running at greater than 4 nines for almost a decade now, in part because, we invest the time and effort into reliability up front.
Looking ahead, what's next for Gremlin? Of course, don't share a lot of, we will talk about news that is ready, but where is Gremlin heading? Are you also exploring support for things like AI infrastructure, LLM latency injection, or distributed models, fault testing? Just give us a glimpse of what else Gremlin is working on.
Yeah, so we released a GPU Gremlin in this last year, which very much is whether you're in the Bitcoin world or you're in the AI world, you need GPUs to run and train your models. So what happens if that fails? What happens if things aren't working correctly there? We see a lot of these jobs are really batch processing jobs. And so they're actually quite expensive if they fail, if you have to rerun the entire batch. And that's a little bit of a different set of failure semantics than the SaaS world. In the always on world, it just needs to be up and work. In the batch world, it doesn't have to be on all the time, but when it fails, it sets you back hours or days worth of work. I think in general, we're excited to just see how reliability changes. For a little while, I thought, reliability is going to be a solved problem. We're going to be worried about other things. And then we've thrown all this AI generated code in the mix. And I'm like, oh, great. No, we got plenty to do for the next, 10 or 20 years while we go figure that out. But the guiding philosophy has really always been make it easy to do the right thing. We got complicated systems. We have complicated jobs. So how do we become the engineer augmenter? How do we go in and make that engineer just better with the skills they already have today? And that's where we help them know what tests to run. We help them analyze the results of the test. We tell them what they should go do to fix it. We gather all the data and make them pretty pictures so they can give them to their boss and say, here's all the progress we made this year. So I think, in a general philosophy, just continuing to empower engineers and make it easy to build reliable systems, that's our focus.
Kolton, thank you so much for joining me today. It's always a pleasure to talk to you. There is so much to learn from you. And after listening to you, it's quite clear that the future of reliability isn't just about surviving failure. It's about embedding intelligence into the infrastructure itself. So thank you for your great insights, and I look forward to chat with you again. Thank you.